Hello everyone, today we are going to find the derivative of y equals to in to the power of 2, open bracket, x plus e to the power of 3x, close bracket. First, let's rewrite this notation so it's easier to see the layers. We can write it as y equals to in, x plus e to the power of 3x, close bracket, to the power of 2. To differentiate this, we use the chain rule. Let's substitute the inner function by letting u to in bracket x plus e to the power of 3x. This simplifies our main function to y equals to u to the power of 2. If we differentiate y with respect to u, we get dy over du equals to 2u. Applying the chain rule, we have dy over dx equals to dy over du times du over dx. Substituting our dy over dx into the formula give us du times du over dx. Finally, replacing u back when its original expression, we get dy over dx equals to 2n open bracket x plus e to the power of 3x times d over dx in open bracket x plus e to the power of 3x close bracket. We need to find the derivative of this inner log part. Let's focus strictly on finding that inner derivative where u equals to in open bracket x plus e to the power of 3x close bracket. Because this contains another inner layer, we need to use substitution a second time. Let's choose a new variable v and set v equals to x plus e to the power of 3x. This change our equation to u equals to inv. Differentiating u with respect to v give us du over dv equals to 1 over v. Once again, we apply chain rule formula for this layer. Plugging in du over dx equals to 1 over v times dv over dx. Now, let's find dv over dx. Since v equals to x plus e to the power of 3x, its derivative with respect to x is 1 plus 3e to the power of 3x. Now, are ready to substitute everything back. Taking our equation for du over dx, replace v with x plus e to the power of 3x, and we replace dv over dx with 1 plus 3e to the power of 3x. That gives us du over dx equals to 1 over x plus e to the power of 3x times 1 plus 3e to the power of 3x. Multiplying them together simplifies the inner derivative to du over dx equals to 1 plus 3e to the power of 3x over x plus e to the power of 3x. Putting it all together into a clear fraction gives us our final answer. Dy over dx equals to 2in open bracket x plus e to the power of 3x close bracket open bracket 1 plus 3e to the power of 3x over x plus e to the power of 3x. And that is the complete derivative.
Today I will explain how to find dy dx using implicit differentiation. The given equation is log 2 minus e power 1 minus x plus xy power of 2 plus 1 equal to x divided by x plus 1 plus 3y. So the first step is differentiate the left side. So for the step 1, we use chain rules because it is a logarithmic function with another function inside it. So we got this answer. For the xy power of 2, use product rules because it is the product of two functions, is x and y power of 2. So the formula this. So for the u, we got x. For the u prime equal to 1, v equal to y power of 2, v prime equal to 2y dy dx. After we got this, we need to substitute the value into the product rule formulas, which is this formula. So we got x 2y dy dx plus y power of 2 1. After that, we simplify it by expanding the multiplications like this. For the third term is the derivative of a constant is 0. After we differentiate the left side, now we differentiate the right side. So the right side is 2x divided by x plus 1. This. We use the product rules. So we got 2 equal to x, 2 prime equal to v equal x plus 1, v prime equal to 1. After we got this all, we expand them in the formula, which is this formula. So we got this. After that, we simplify it by expanding the multiplication. So we got this. Then we cancel out the common term, like 2x and 2x. So we got 2 divide by x plus 1 power of second term is 3y. So we got 3 dy dx. If have a y, we need to put like this. So step 2, we combine all the right side and left side. So we got e power 1 minus x divide 2 minus e power 1 minus x plus 2xy dy dx plus y power 2 equal to divide by x plus y power of 2 plus 3 dy dx. So the step 3 we collect the dy and dx. After we collect dy dx, we got 2xy dy dx minus 3 dy dx equal 2 divided by x plus 1 power 2. So after that we factorize out that, so we got this. So the final answer for the question 2 is this.
In this question, we are asked to use differentials to estimate the value of the square root of 15.8 minus 2 divided by the fourth root of 15.8. First, let f of x is equal to the square root of x minus 2 divided by the fourth root of x. To differentiate more easily, I rewrite the function as f of x is equal to x to the power 1 and half minus 2x to the power of negative 1/4. Since 15.8 is very close to 16, I choose x is equal to 16. Therefore, dx is equal to 15.8 minus 16, and we're gonna have negative 0.2. Next, I will find the value of the function at x is equal to 16. So we have that f of 16 is equal to the square root of 16 minus 2 divided by the fourth root of 16. As we know that the square root of 16 is equal to 4 and the fourth root of 16 is equal to 2. So we're gonna have 4 minus 2 divided by 2, and we have 4 minus 1, so the answer is 3. Now, I differentiate the function using the power rule. F prime of x is equal to 1.5x to the power of negative 1.5 plus 1.5x to the power of negative 5/4. Now we're gonna substituting the x is equal to 16 to the function above. That will give you f prime of 16 equals to 0.140625. Using the differential formula, dy is equal to f prime of x multiplied by dx. I get negative 0.028125. Finally, using the differential approximation, f of 15.8 is approximately equal to f of 16 plus dy. So we're gonna have 3 minus 0.028125. As the final result, we will get 2.971875. And correct it to the 4 decimal places, f of 15.8 is approximately equal to 2.9719, and the final answer is 2.9719.
This is the question for number 4. Answer for question number 1 is differentiation is the process of finding the derivative of a function. The derivative measures the rate of change of one variable with respect to another. Conceptually, differentiation helps us understand how a system changes over time. It shows whether a quantity is increasing, decreasing, or changing at a particular rate. This information is useful for analyzing trends, predicting future behavior, and optimizing system performance. For question 2, for a computer science example, differentiation can be used to monitor website traffic during an online sale. Website visitor may increase rapidly. By analyzing the rate of change in traffic, developers can predict heavy usage and add more server resource before the website becomes slow or crash. So this helps monitor system load, detect sudden changes, and keep the system running smoothly. For question number 3, critical reflection. We learn differentiation because it helps us understand how things change and improve our problem-solving skill. In computer science, it can be used to analyze data and improve system performance. As a future computer science professional, we can use differentiation to make software and system work better and more efficiently. So the conclusion is differentiation is a useful tool, help us understand changes, solve problems, and improve technology.